Hello everyone, how are you doing guys? I am here another talk in SouJava on campus and I will show you this event for us, okay, for us, sorry. And today it's very full, having many peoples here and it's very cool. And we have a lot of stands and the companies here, a lot of communities, and they have a lot out in the same time. And it's I don't know if you see, but Bruno Souza giving talks and Arena Disrupção. And today it's a good day, and today Brazilian is very hot. It's more specific in São Paulo is very hot, but I don't say many things about the event because we have a great person to give you a talk today. It's a Buzzler. Hey Buzzler, coming.
Hey, how are you doing, man?
I am doing okay, and you?
Doing fine.
All
Thank you
right.
for asking.
Buzzler, you say many things today about Java, very lot futures. This is true. I have interest about this because I have one talk and I say little futures about Java, and I am very anxious to actually to talk because I have a similar talk you show today, and I am
Oh,
anxious.
all right.
All right, Buzzler, I will go to backstage. If you have a doubt or problem, you can scream me my name, and I enter here. And one double my one double. If you have a question, you prefer and to help to you or questions in the final, and you receive the question in the final talk.
So here's the thing. When I'm gonna go the full screen, I'll probably not see anything. So
Yeah.
if there is a question, just ask me directly.
Oh, okay. Okay. Perfect. I will go to backstage now.
All right.
It is a stage for us. It's the moment to rock. Let's go.
All right. So thank you for hosting me. It's I have seen your I've just seen your program campus party. It's a huge thing. I wish I could join you in person, but anyway, better at least I'm able to join virtually. That's great. Then at least not joining at all. So I'm super excited to be here. All right. So the idea is about today's talk is basically about the little feature, the smaller feature. I mean, there are a lot big feature over here. I'm gonna pick top 10 that I like most. I mean, you all know that there are plenty of features available in Java, and you probably know already all of them. So anyway, however, since Java 9 we have we have sort of getting a new JDK every 6 months, which is great thing. With that, a lot of new features are also coming to Java. Sometimes it gets even difficult to keep it up. That's why in this talk I'll share the 10 10 feature that I love most, and I believe these 10 features can help you our day-to-day programming a bit better. So that's the goal. All right. So if you know them already, I mean, the feature that I'm going to show you today, that's awesome. Which means if I make mistake, you'll be able to correct me, right? So feel free to correct me if I make any mistakes. And though if you don't know about those things, that's even better. You're going to learn something new. So that's all. Without further ado, let's start the topic, which is top 10 Java language feature that I like most, I love most. um, a little bit about me. I'm going to skip this slides, just to if I share this slide with you, you'll be able to know about this. But for this time being, I'm going to skip this slide anyway. So the first feature that I'm gonna talk about is collections factory method. I'm pretty sure everyone, all of you, know about it. But just to reiterate, the collection are the most frequent used feature in our daily coding, right? They are used to basically collection are used as a container where we store object and then pass them along to other things. We pass them into a method, we return from a method, all sort of things, right? So collection are also used to sort, search, iterate object, and making programmer life easier. It provides basic interface including list, map, set, etc. And we all of them has a multiple implementation. But we don't always want them to change data, right? Sometimes we want to have immutable collection to use them. For example, we have a few data that we want to keep as it is, but we want to keep it in a read-only fashion. The traditional way of creating immutable collection and maps may look a little bit verbose for many developers. Let me give you an example. For example, this one, you know. If we want to create immutable names of a few countries, we're going to do something like that. We'll call arrays.as list, and we'll put this value. And then if you want to make it immutable, we have to call this another method, which is collections.unmodifiable list. So there's the two things we need to do to accomplish this. um, uh, but as you can see, uh, these are we are doing multiple things over here. What if we have a easier ways to do the same thing with less a line of code? Luckily, that's why Java 9 introduced few very concise factory method. uh, you know for example, this if we want to create the immutable list, we can just call this method list.off. That's it, we don't have to do anything. Similarly, if we want to create a immutable set, we can call this set.off, and we get the immutable set, and it works for map as well. These are very convenient way to make immutable containers. you know However, if you're going to create mutable collection, then obviously we're going to use the traditional approach, which is you're going to instance instance perhaps array list, linked list, whatever the requirement. It is based on your requirement, you're going to choose an implementations. But if you need an immutable list, you can, or small list that you can just pass along some data, then collections factory method are super useful to use. All right, moving on. So next one that very favorite and very near and dear to me, which is local variable type inference. So Java 10 introduced type inference for local variables, which is I personally believe it's super convenient for developers. Traditionally, Java is strongly type language, right? We all know that, and developers have to specify type twice while declaring and initializing an object. It seems sometimes tedious. Let's show you an example. So this one, right? We have created a map, and we have specified the type twice, a left hand side and the right hand side. So if we define it one place, our eyes easily can interpret that it has to be a map, right? For example, if we declare left side, we can understand the right side also has to be a map type. Java language has matured enough, and compiler should be smart enough to understand that. The local type inference does precisely that. And the above code is now can be written as follows. You can declare just var, and you can put a name, and then all the type information goes to right side. So that's an interesting feature. uh,
I enter here because I have a little discussion about this
sure,
feature.
sure, go ahead, go ahead.
It's this feature. I like this feature, but a lot of developers have a little hate because, like the right the typo and the variable, you know,
All right.
and this feature is amazing. But have a moment you code, you feeling lost, you code because do you remember the type?
Yes, I understand where are you coming from, and it's true that it seems handy features, but there are some criticism as well. I mean, some developer would argue that this may reduce readability, which is more important than this little convenience. I agree with that. So that's why there are some style guides available, which you can look into. I have here some links I can share with you. So, and there are some principles as well, which we can follow while using this local type inference. For example, the first principle is basically we have to keep in mind that reading code is more important than writing, right? So if it is reduce the readability, then we'll probably don't use it. So that's the first principle. And the second sorry about that, something went wrong. Okay. So second principle is code should be clear from the local reasoning, which means the reader should be able to look at the var declaration along with uses of declared variable and understand almost immediately what's going on. So we have to keep that mind, because it coincides with the first principle as well. Reading code is more important than writing. So if you write var in your code and if it's difficult to read, and if it's difficult, you have to go from one place to another and you have to scroll, that's probably not ideal place to use local variable. There are some use cases where you should definitely use local type variables. It will reduce clutter, but you have to keep that in mind, which is reading is more important. So the third principle is basically code readability shouldn't depend on IDE. you know that's in fact we all use ID, right? Often written and read within the ID. So it's sometimes tempting to rely heavily on code analysis features of ID. However, code is often read outside ID, right? Code appears many places where ID facilities aren't available. For example, code review tool. If you are reading in your GitHub or any other code review tools, so code should be self-revealing. It should be understandable on its face without needing the assistance of IDE or any sort of tools. So we have to keep that in mind. That's the another guiding principle. And the final guiding principle is explicit types are trade-off. We have to keep that in mind. Java has historically required local variable declaration to include the type explicitly. That's why we declare twice, left side and right side. But if we remove it, if we omit the type from one places, it's helpful. Omitting an explicit type can reduce the clutter, but only if it is if it doesn't impair the understandability. So we have to keep that mind. So these are the guiding principles that are available. And I have source over here. I will share this links with all of you. If you want to, if you are interested, you can read it. But this is a sometimes it's very useful. You have a method, inside method you have a lot of long type, and if you just use var, that probably going to help you a lot, and you're going to reduce line as well. So it like the principle for it's a trade-off. You have to decide when to use, when not to use. All right. Any more questions? All right. If you don't have questions, I'll move forward. Moving on to the next feature that I really like, which is enhanced Swiss expression. The traditional Swiss statement has been in Java, from the beginning, which kind of resemble the C and C++. It was okay. I mean, we have been using it for many years, but as the language evolved, it hasn't offered as many improvement until Java 14. So it certainly has some limitation as well. The most infamous was fall through, right? We all know about that. So something like this, right? you know in case 1, 2, 3, 4, it fall through until 5, right? And if we don't have any break statement, it will go to the bottoms. So to tackle this issue, we use usually break statement, which are pretty much boilerplate code, right? We For example, this code, we have a few break statement, but what if we had like had to write 7 break statement? So that's a lot of unnecessary code. However, Java 14 introduced a new way of looking at this switch statement, and it offers much more features. For I can give you an examples over here. Same code over here, which is 18 line, and it can reduce into six line, and we don't have those clutter. We no longer need to add break statements. It solve all this fail through problem. On top of that, switch statement can return a value, which means we can use it as an expression and assign to a variable. That's an amazing feature. And I have seen in many production code, like the previous old way of using switch expression, and if we can refactor them with the new way, which is introduced in Java 14, we can reduce a lot of line, and it removes a lot of clutter. So it's an opportunity to refactor your code base if you see in your production environment and you are happen to use the latest Java. I recommend highly to use the latest one, which is probably the LTS one is 17. So go ahead and use the 17, and you will get all these benefits, which is amazing. All right. So moving on, I'm gonna go ahead with my next one. Unless if you have any questions, if you have questions, just you can ask me anytime. So all right. Um, so let me go ahead with the next one, which is this is a reference that if you want to know a bit more about this enhanced expression, you can go to this link. They have a huge, they have an article which explain all these cases. All right. So the next one is super useful, I would say. And it's relatively new features and released in Java 16, and I find it super helpful to create immutable objects. Sometimes we want to create immutable objects, we want to just store certain elements and we want to pass them to other methods, and we want to make sure that they don't get changed, right? I can give you an example. For example, if we need to a data carrier object in our program that hold or pass values from one method to another, for example a class that carry xyz coordinates, right? And which we would write like this. So we'll have a, let's say we have a point class, and it has it has three a field xyz, and we'll have constructor, we'll have getter, and then we'll have equals, hash code, all those things, right? It's 48 lines of code, and this class seems super verbose and has little to do with our whole intention, right? We have to achieve one thing, and to achieve that one thing we have to write whole lot of things. I understand this can be written in IDE, written with IDE. IDE can sort of generate all these things, but again, if it is automatically generatable, why I have to write them? We have to keep carry all those informations. So this that's why record that's where the records comes, and this entire code can be replaced with following one line, which is interesting, right? Public record actually. So
Uh, I
any
can't hear. You hear me clear?
Yes, I can hear you.
Oh, all right. In the community say it is the possible change. You don't use more Lombok and use only records. What do you think about this? Because
So
records you can use get, set. It's a similar little Lombok.
Lombok is super useful. I do use Lombok for many cases. The
Yes, I.
problem is, yeah. So the thing is, Lombok is an external library, right? First of all, you have to add this in your code base. You have to, carry another extra burden. But record is basically available with JDK. You don't need to have anything else. You can just use it. But again, record solves only one problem, which is if you need immutable, object. But what if you need a mutable one? then probably we're going to go with the traditional one, which is the traditional way of creating classes. And in that case, Lombok is definitely super useful, and the use of Lombok is not removed. I mean, we
So,
still have to use Lombok. So
yes, Lombok not make objectives immutable. And I hear another things. It's record is very security because this it's immutable,
right, right, it's
right?
immutable.
Yes, it's go ahead. Sorry, it's a a little double. My double.
No worries, no worries. Whenever you have a question, just ask me immediately. I'll stop and I'll try to answer these questions. But yeah,
Oh,
I
okay,
mean,
okay.
yeah. So it's a new thing. It's came in Java 16, and there are many use cases of record. The main use cases would be, if you want to create just data and pass data. And there is another interesting feature that's coming along in Java 19, which is you can deconstruct record using a pattern matching. Probably when we are gonna talk about it, it will make more sense, and that's where record usually helps a lot. Anyway, but in general cases, if you need an immutable object, you can use record, and you don't have to rely on anything else, any third party libraries, which is Lombok is fine. But if you don't, if you don't want to rely on that, that's super, that's fine basically. I mean, it's just another external library. If you have less dependency, that's better. All right,
In
so
only
moving.
processor is because you don't import, not make import.
All right,
Go ahead, go ahead, go ahead, go ahead.
moving on. So the next one, which is number 5, is optionals. And I am super, I have been using optionals for many years, and I really like it. uh, okay, so let me give you the reasoning why I like it. When we uh, you know method is basically a contract, right? We put our thought into it and we define one. Basically, we specify the parameter with their types. We also specify the return type, and when we write our contract, we expect it to behave accordingly, according to our contract, right? We When we want to invoke this method, we want to call a method, the contract said it should return a string, and if it doesn't, that means it's a violation of contract, right? So you know that's a case. The method says it should return a string, but sometimes it doesn't. It returns null. That's a violation, right? uh, so if a caller or invoker cannot know upfront unless it invokes it, right? There is a method. It says it should return a string, and we can know only when we call it, and we end up getting null pointer exceptions. And that's a problem, right? So to tackle this violation, we usually test the value with if condition, whether this value is null or not. And there is an example over here. You can see over here, we call this method called find name, and we sort of the find name method over here if you see the contract, it says it should return a string, but again in the body we are returning null. That's a problem. And the invoker, which is from the main method, there is no way to know that, right? Whether it's going to be a null or not. But since we have been doing this, we have been experienced, and we know there is a possibility of a null. That's why we write this clutter ugly code, which is if name is not null, then we're going to do certain things. uh, and if we don't do this, obviously we if we call this, the name is an object, and if we invoke a method on top of it, which is name.length, it's going to throw a null pointer exception. So that's a problem. On the other hand, if the method signature would specify the possibility of not being able to return a value, it would solve all this problem, right? And that's where the optional comes into play. So let me show you another code bases over here. You can see in this code base, in this left side code, in this left side, the find name method basically return optional. And when we're going to use this method find name, we know upfront which is that this find name may return empty value. It may return the value, or it may not return the value. And since we are aware of the fact, then we can sort of proceed. We can decide upfront that we need to check it whether the value is present or not. And then if it is present, we are going to do certain things. If not present, we are going to do certain other things, uh, like the if condition. But over here on the left side, we are more aware, so there is no way to make mistakes. And on the left side, there is a possibility of making mistake. What if we don't remember of doing the if condition, right? So that's a fix. It just sort of gives upfront warning to the programmer and fixes the violation. And not only that, we can do a lot of other interesting things with this optional, because it has a lot of interesting methods, that we can do things, rather than imperative. We can do things functionally. We can do things, we can do chain, and they could become more fluent. Let me give you an example one by one. So let's see, if gate name is present and we want to do certain things, we can call we can call this if present method, and we'll get a lambda expression over here, which is s. That means this lambda expression will be invoked only if if there is a value. Otherwise it will not be invoked, right? What if we can do this same way. You can do this with if expression as well. It's the same thing, but I would rather prefer the earlier one. It's a more what do we say, it's more it's a one liner. First of all, it's a lambda expressions, and it looks nice. It looks functional as well. Let's see another example. What if we have to do two things. For example, uh, if you want to invoke you want to do certain things when value is present, and if there is a no value, we can do other things. We can use this if present or else method, and it takes two lambda expressions. So that's also interesting. Let's see another example. We can do or else. For example, if let's say if we want to call this method get name, if the value is there, we're going to use it. If the value is not there, we're going to set a default value. We can just call get name dot or else. That's also doable using this optional. The other thing is, let's say, the the over here, sorry about that. It's going to bring all this. That's a problem with this slide. I'm extremely sorry about that. Anyway, so there is another method called or else get. This is interesting method because when you call get name dot or else, if it is a method, it will immediately call this method, right? And if you want to delay the calling, then we can use this or else get. This method will only invoke if this value is not present. So if find the default name is a costly operation, we can delay the invocation. So it's a sort of lazy evaluation, we could say. So we can use this approach if we need to use lazy evaluation, and the find the default name is the expensive operation. We don't want to call it unless it is required. Then we can use these methods. So there a more interesting way to use optionals. For example, we can use over here, which is a method. We can use this. What do we call it? Um, I forgot the name. Sorry about that. We can use this approach as well. All right. So there's two other methods available with this optional, which is map. For example, let's say we got a name with the get name, which returns optional, and we want to transform it into a uppercase letter. We can just call it, map dot string uppercases. And if we want to call another method inside this map, we can, for example, we want to get a full, we want to get a full number, and full number also returns an optional. We can call this flat map, and this get name dot flat map, and then we are going to get a name. With this name, we are going to call get full number. So end of the day, we're gonna get a phone number as a return from this whole expression. So we can sort of chain all those things, interesting things with optionals, and these are super useful when you are gonna use them. So yeah, that's a really interesting feature that I really like, and I use a lot in production environment. So here you go. I- i- if you like all these examples, you can use it now as well. All right, so moving on, I'm gonna go ahead a bit faster because I have more, 5 items to share with you, and I'm not sure we'll have a lot of time to share all of them. So I'm gonna go a bit faster from now on. If you have questions, please ask me. I'll pause and I'll reply or answer, if I in fact can answer your questions. So all right, moving on. uh, the number 6 is Java datetime API. Every developer is is confused with datetime calculation to some degree, and I can surely say that this is not an overstatement. I have struggled a lot earlier, and this was mainly due to not having a good Java API for dealing with dates and times in Java for a long time. However, the problem no longer exists, because Java 8 brings an excellent API set in Java.time package that solve pretty much all of our problem. And they have in this package they have like all these classes, which is local date, local time, local date time, duration, periods, zone time date, offset date time. That with this, it has a lot of factory methods. You can use them easily. If you want to calculate, you want to differentiate, you want to uh, you know set a date in a different time zone, and you want to calculate them, you can easily calculate all of those things with this set of classes, and these are super convenient, and I can show you some example over here. For example, this one, if we want to create a local date, we can just call local date off, and we can provide year, month, which is an enum. That's also super useful, because earlier we had to use 1 to 12, uh, 0 to 12, I think. I forgot exactly. But if you put 13, or if you put -1, that's a problem, right? And you will get an exceptions. But now, since it's enum, you cannot do any of those things. So that's super convenient. And if there a convenient method, for example, get year, get month, a day of month, day of weeks, you can also know from a local date if it is a leap year. You don't have to calculate them. You don't have to write a new method to calculate if it is a leap year or not. You can just call it is a leap year, and it will return true or false. So these are super convenient, and there are a few others. For example, if you want to calculate with time, then you can use local time in similar things. There is a factory method, local time dot off, and you can provide the time over here. And you will have a lot of methods as well, and you can sort of use, for example, there is a time and you can add 3 minutes to it. You can just call plus minutes, and you can put 3. So these are super convenient. And if you want to work with time zone, there are also a API available in this package. With time zone, you can do all sort of stuff. Before this API, it was crazy difficult. Now it's crazy easy, I would say. uh, so all right. Moving on, the another helpful features that Java 8 has, sorry, Java 14, I think, which is helpful null pointer expression. This is a smaller feature, but I believe it has a super benefit. It has a lot of benefits having these helpful null pointer exceptions. Because every developer helps null pointer, I mean, hates null pointer exceptions, and it becomes challenging when stack trace doesn't give you any helpful information. So let me give you an example. Let's say this code basis over here, and we have two classes, user and name. You see, user has a field name, right? So basically, if we have a user, we can call user dot names dot and then we can go ahead first and call the first name. So what if user itself is null? That's then it's going to throw a null pointer exception. For example, in line number 9, you see I call user.name, which is going to give me a name object, and then from that name object, I'm going to call this first name, right? Which is name.first name. But user is null over here, uh, so it definitely is going to throw a null pointer exceptions. The problem is if I see this check trace, it gives us to certain degree information to some information, but it doesn't tell me exactly where the null pointer exception happened. It just gave us a line number, which is line number Java 11 and line number 7, but it doesn't add any more information to it. This is fine, but if we had more information it would be much easier, right? However, in Java 14 and onward, we get much more information in this tech test, which is super convenient. For example, if you run this program in Java 14 or later version, you will get this helpful information. For example, cannot invoke user.name because user is null. Now I know which object is null. Earlier I didn't know. I have to evaluate. I have to look at this stack trace and figure out which can be the possible region for null pointer exception. Now I exactly know why there is a null pointer exception and which object is null. So this is super convenient, and I find it helpful. And it's especially helpful for the beginners who struggle it a lot. When I was beginner, null pointer was sort of a nightmare for me, and I struggled a lot. So if you use the latest Java version, and you don't have to go through all this struggle anymore. That's definitely super convenient things. All right. So moving on, I'm gonna go ahead with the next one, which is new form of instance of. This is also another smaller feature, but very useful, I would say. Look at this code base over here. So here's the thing. Think about, we have the abstract class, which is animal or superclass, and then it has multiple subclass, which is cat, dog, and all sort of things. And based on the subclass, we're gonna invoke certain methods. For example, over here, if it is a cat, we can call this cat.mew method. If it is a dog, we are going to call this dog.off method. But problem is we have over here we have the reference of superclass, and we don't know whether it is a cat or animal. So what do? We do use instance of. And while we make sure that animal is instance of cat, still in the second line we have to cast it to a cat. Uh, that's a over here from the line 1, we already know that if this line 1 is true, then it's a cat. Why again we have to sort of cast it in line number 2? Doesn't make sense, right? It's another additional code that we have to write. And from now on, you don't have to do that in the latest Java. I forgot exactly which version of Java this feature has been added, but uh, you know it's definitely into the latest Java version, which is if you can declare a variable right side of this instance of, which is animal instance of cat. Then you can create another variable which is cat, and you can just call cat.meow. You don't have to add this additional line, which is super convenient. It's become extremely convenient when you have a huge hierarchy. And I have seen this sort of example in production code, and it seems smaller things, but it pays off when you have a large code bases and you have a large object tree. So yeah, it's super useful. All right, moving on. Let me go with the next one, which is pattern matching for switch expression. All right, so now we have use of instance of. Based on that, there is a new feature also involved in Java, which is pattern matching, and we sort of all wanted these new features, right? Let me give you an example over here first. So the example is, let's say I have a method over here which is get formatted string, and I can pass an object, and based on object, I want to get a formatted text. For example, if it is an integer, I want to format it certain way. If it is an long, then I want to format it different way. and for double and object is vice versa, basically. So in the earlier example, we have got this new instance of, we can use this, and we sort of remove one line on each if block, right? uh, this is great. uh, but again, we are doing a lot of if else over here. This can be replaced with the pattern matching for switch expression. This is a new feature, and we can sort of reduce this 13 line of code into 8. We don't need to do any those if block anymore. We can just use switch expression over here. And if it is an integer, we're gonna return string dot format a certain way. If it is long, it is double, it is object. So these are improvements. So gradually Java is improving to you know you know m- becoming more nicer programming language, and more less code we have to write, and it's more convenient and more it's easy to read as well, right? So the first thing was is the number 9 was small use cases. I mean, small changes, but it's convenient. From on top of it, we are now going to go get the Swiss expression, which is more convenient. So building on top of one, we are getting more things. All right. So it has a huge use cases. We can think of. There is an article in InfoQ. The link here's the link over here. You can definitely want to read this article, and it explains how pattern message is going to change the way we are going to write code, and it's going to be a revolutionary things. So go ahead and read this article, and I have copied a code snippet from this article that I can show you over here. Let me show you that. So let's think about this code bases. For now, forget about the sealed this sealed keyword. I haven't added this in this presentation, so forget about it for now. Just think about, we have a interface which is match result, and it can have multiple implementation. For example, over here, no match, exact match, fuzzy matches, and there is another one which is fuzzy match, right? So let's say we have a method which is find user, and we're gonna pass a username, and based on there is a certain things it's gonna do, and based on this, it's going to return me a match result, which is an interface. uh, and now when we're going to invoke this method, we don't know, when we receive this match result, which is an interface, we don't know what implementation it is, because it's going to get, we are going to get it on runtime, right? So using this pattern method, ideally earlier, what we would do, we would do if else. If match results is instead of no match, we're gonna do certain things. If it is an exact match, we're gonna do certain things, vice versa, right? Uh, but we can do this entire things with pattern matching. It makes our life super convenient, so easy and simple. For example, this user search method, which is send me an user, and I can call this find user and method, and we can do switch over it, and we can do case clause, something like that. So find user is going to give me a match result, which is an interface. Based on that, we can write cases. For example, no messages, exact messages, and fuzzy messages, and all sort of things we can do. So these whole things, which is nine line of code over here, does a lot of things. But now think about it. If we had not this pattern missing, we had to write a lot of more lines for this same amount of same features, right? So yeah, it's going to be a super convenient. So read that article, and definitely we're going to be amazed what are the interesting and amazing features that are coming along in the Java ecosystem, I mean Java programming language. So I'm super excited, and I'm looking forward to it. This is available in Java 19, and if you haven't downloaded or tried out Java 19 yet, go ahead and try out. Probably it is still under preview, so you have to enable the preview features. So keep that in mind. All right. The final one is Lambda expression and Stream API. I definitely don't want to talk a lot about it because it's been here in Java for a long time, since Java 8, and we pretty much everyone use Lambda expression and Stream API. And I just wanted to put it over here because it's the most favorite language features that I have been using heavily in production environment and in my day to day programming. Doesn't have to be production. It could be your pet project. It could be your assignment. It doesn't really matter. But we are using this Lambda expression and Stream API heavily, and it's super convenient. Using this, we can now write functional programming. We can now declarative programming. A lot of interesting thing we can do with this. I just wanted to put it over here. I definitely don't want to go into in depth on this particular topics, which is Lambda expression, because it takes a it's probably begs a whole session, and I'm not sure if I have that time today. But if you haven't, if you don't know yet, please go ahead and try out. There's plenty of resources available in online, YouTube article. It's been there for many years. So um, you know go ahead and try out. So I want to definitely quote a line from Venkat Subramaniam, which is, I think it's super useful. I mean, it's a nice quote, which is Lambda expression are the gateway drugs to Java 8, but streams are the real addiction. So once you are used to with Lambda expression and stream API, are going to be addicted. So that's what it says. That's what he says basically, and I completely agree with him. It's super useful features, and I have an example over here, just to show you how cool it is. For example, look at these methods, and let's say I have a list of books, and I want to do certain things. For example, I want to filter them. For example, I only filter all the Java book from this list. And traditionally we're gonna do like this. It's an imperative way of doing things, right? We're gonna declare a variable over here, and then we wanna iterate loop over it, and then we're gonna do a if blocks. If it is a Java, we're gonna put that into filter book, and then if not, we're not gonna put in this filter book, right? So filter book is basically our filtered array list. And then let's say we wanna sort of uh, sort it with a comparator. We're gonna do is this, like, we're gonna sort with a comparator, and then we wanna we want to get this name only from this book list, and we want them in a comma separated way. So we have to do another loop. It's a 22 lines of code, and over here we know our intention, right? We know that we want to from this list of books, we want to filter out the Java books, and then we want to sort them, and then we want to join them in a comma separated way. These are our intention. Also in this code we're writing how we are going to achieve that. So basically it's a whole imperative code. These whole things, 22 lines of code, can be written in 7 lines using Stream API and Lambda expression. Same thing, but over here we are more of a sharing or commanding our thoughts to programming language or tools. We are asking them. So I want to filter. I want them sorted. I want them only name, and then I want them joining by comma separated. And I don't know how we are gonna give that, but this is my intention. So it's more of a declarative way of doing things. We are not dealing with the how part. We are more of a describing our problem, and we are going to get solved by the tools, by the programming language itself. And that's an amazing thing. So that's all I had. This top 10 language features that I hold, I really like and love, and I use all the time in my day-to-day programming language. There are plenty of other features, but these are the selecting top 10 is difficult job, and definitely I missed a lot of other features over here. So if I could do a top 20 or top 30, I would probably I could probably do the justice, but yeah, selecting 10 is difficult. So yeah, that's all I had for today. And if you have more questions, and if you want to reach out to me, feel free to follow on me on Twitter. And yeah, you can reach out to me. That's the only way you can that's the only place I am very active. So uh, if you have any questions related to Java, any feature, any new things, any confusions, you can you definitely reach out to me through this Twitter. And so go ahead and follow me. That's it. That's all I had for today's session. And let me know, if you have, questions.
Bosworth, how you doing, man? So
I'm doing great.
that's awesome. So good to have you here.
Thank you. Thank you.
Thank you so much, man. Thank you for being here with SouJava, right? We're
I wish.
not only this time, but many times, right? You're always here with us. You're probably one of the guys that participate in every single one of the SouJava campus that we did. So thanks a lot, man.
Thank you. Thank you. I wish I would be joined in person, but at least online, that's also okay.
Yeah, I know you're solving your visa issues there, right? So is that solved already?
It's not, but hopefully, soon.
All right. Okay. Cool. So whenever you're ready, right? Brazil's here waiting for you.
Thank you. I can't wait to join you in person. I met some of you already, but I definitely want to meet you in person, and many
Uh-huh.
of others as well. So I'm super excited to join you
That's good,
when I
man.
am able to.
Awesome. So thanks, man. Thanks a lot. I think we got all the questions already answered, right? So, um, guys, go follow this guy, Java champion, Java's group leader. He's doing an international career, an amazing international career. So, thanks, Pazlor. Thanks for being here. Thanks, everyone, for joining us. Is this the last one today? No. Okay, we still have one more talk today, right? So thanks all of you. You guys here watching, participating. You've been awesome. So today, campus party. Today's the last day of the content here at campus party. Tomorrow is just people going home, right? But we're still gonna do camp. So Java at campus tomorrow. It's still gonna be here with lots of content. So join us tomorrow for even more great content.
All right. Thanks, Bruno. Have a nice day and enjoy the rest of your time on this party.
Okay, cool, awesome.
Bye bye.
Thanks
Bye
everyone,
bye.
guys. See ya. Bye. Thanks everyone. Good to have you here. We have one more talk, so we're gonna close this down and start again on the last talk of the day. Thanks a lot.